Okay, so now let's move on to question number 3. How do you calculate the percent yield of the reaction? Okay, so let me write down the formula for percent yield. So basically, percent yield is the actual yield divided by your theoretical yield multiplied by 100%. So your actual yield is pretty much how much you actually obtained, after performing the synthesis. And to find the theoretical yield, this is when you would use stoichiometry. And also, since we know the mass of reactants we started with, we can calculate how much of the product we expect to have. Okay, so not all the time will we always get 100% of product being formed. There's some human error and some errors that will occur when you perform your synthesis. And because of this, we can get less than how much we expect to have in the synthesis. Okay, so let's see what our junior tutor said. In reactions, we can quantify the mass of the product using measuring equipment, such as analytical balance. The mass always deviates from what is the predicted mass, or so-called the theoretical yield, due to some factors during an experiment. The yield of the experiment can be represented in terms of the percent yield, which is the amount of the products produced in the actual experiment compared to the theoretical calculations multiplied to 100%. Okay, so they have actual over theoretical times 100. So this gives you an insight into how effective the experiment you conducted, depending on the mass of the product you want to produce. Okay, so here they have a nice example. In problem-solving cases, most of the time, the actual yield is given and you want to get the theoretical yield of the experiment. You can simply solve it using stoichiometry. The molar ratio of the reactants to the product will give you the number of moles of the product and solve for its mass by simply multiplying the number of moles to the molar mass of the reactant. So this is an example of why it's always important to make sure that your chemical equations are balanced. So here they have, for example, you want to synthesize a magnesium oxide. In the experiment, your yield is 2 grams by using 5 grams of magnesium metal. What is the percent yield? So here they wrote out the chemical equation. 2 moles of magnesium with 1 mole of oxygen gas produces the magnesium oxide product. The molar masses of magnesium and magnesium oxide are 24.3 grams per mole and 40.3 grams per mole respectively. The next step is to find the number of moles present in the reactant you use. In this case, it is magnesium. So typically, we assume that the oxygen is in excess and that our magnesium is our limiting. But basically, they calculated the number of moles of magnesium that reacted by doing 5 divided by 24.3, and they got 0.21 moles of magnesium. The number of moles of magnesium oxide produced can be calculated using stoichiometry. The molar ratio of magnesium to magnesium oxide is 1:1. Thus, the number of moles of magnesium oxide that must be produced is the same as the number of moles of magnesium. So now they multiplied the 0.21 moles that you find in the previous step, and they multiplied it by 40.3 grams per mole and got a theoretical yield of 8.5 grams. So this mass is your theoretical yield, thus the percent yield of the reaction is 5 divided by 8.5 times 100, which is equal to 58.8%, which actually isn't bad in a synthesis. And this solution is correct. I'm gonna give credit, or just say that it was a good example. Okay, so now we can move on to question number 4.